Hi boys and girls, it's Mr. Yates, and in this video we're going to be going over the answers to the Spiral Math for Wednesday, May 6th. We're going to start off with our first one, which is make a line plot of the measurements in the table, then find the fair share. So basically this is pretty much like exactly what we did on the Wednesday Chapter 11 math test and also in the practice test, making a line plot chart. My tea mug made a little water stain here, but I hate to waste paper, so I'm just going to go ahead and use this anyway. What I'm going to do is I'm going to first be making a line plot, and I'm going to set it up exactly like they had here on the Spiral Math, with 0 at the end and 1 at the other end, because we're talking about miles walked. Nobody walked over a mile. So I'll go ahead and in my answer across from my work, I'll just take up the whole space this time. I'll make a line. The line will start at 0 miles. And I'll make it end at 1 mile. Like I said, no one's walked more than a mile, so that'll be plenty of space. I want to look at the title that they used, and it looks like they used the title here, Miles Walked. So I want to use that in my answer right here, or not my answer, but my title. So I'll call it Miles Walked. They also added a little bit of unit of measurement there to remind you, even though it's kind of redundant, that means it says the same thing twice. Miles walked, and then they also put miles right here, just to remind you that the unit of measurement we're talking about is going to be miles in our chart. The next thing I want to do is I want to take a look at which fractions I should be plotting on this chart. There's a lot to look at here, so I'm going to go through it carefully. The first one I see that will really help me is 1/2. It's an easy one to plot on here, so I'll put 1/2 in the middle to show 1/2 of a mile that some people walked. And as I'm looking through this, I find that, let me cross out the ones that I see that are a mile here. So let me just do that. So I see one person that walked 1/2 a mile. So I'll put 1x, make it kind of small because you're going to be stacking them. You don't want to have them super big. And I'll look around and see if I see any more 1s, halves, and there's another 1/2. So now I have 2 x's. Show that 2 people went 1/2 of a mile. Next one I'm going to do, let's look for the 1/4. I see somebody here that went 1/4 of a mile. So I'll plot here 1/4. I'll make the X to show that one person so far went 1/4 of a mile. I want to make it even with the X that shows that one person went 1/2 of a mile, right across from each other like that. And I'm going to look around and see, oh, there's somebody else who went 1/4 of a mile. So I'll cross that one out. And I'll put an X on top of the other X, making sure that they're even with the second X over here. So now I have 2 people that went 1/4 of a mile. Looks like that is everybody. So the next thing I'm going to do is look for, oh, let's do 3/4. 3/4 is pretty easy. That's right there. And I'll go ahead and cross out the first one. That shows somebody going 3/4 of a mile. And there's another person right here that went 3/4 of a mile. And again, it looks like it's 2 people went 3/4 of a mile. This guy's starting to get a little above the other 2, so I want to make sure that I don't make it too big. I like them nice and even. It just makes it easier to understand the chart. Now, the next one I'm going to do is 1/5. 1/5 is going to be less than 1/4. The bigger the denominator, the smaller the fraction if it's just 1. So 1/5 is going to be right about here, maybe. It doesn't have to be exact, but let's say we'll put it right about here. 1/5. Now for this one, boys and girls, what I'm going to do is I am going to cross out my 1/5 person. Looks like only one person is doing 1/5 of a mile. So let's make 1x. And I also see the fraction 2/5. So I'm going to put that right after 1/4, right about here. So it's 2/5. And what I'll do here is I'm going to look. I have one person who went 2/5 of a mile. And there's somebody else who went 2/5 of a mile. And I think that's it for 2/5 of a mile. Now the final fraction that I'm going to be looking for here is 1/3. Looks like everybody else just went 1/3 of a mile. I'll put that after 2/5 right about here. Kind of crowded in the area underneath 1/2, and just make sure you put space enough between them so that they're pretty easy to see. So it looks like I have one person who went 1/3 of a mile. Put my X down. Got another person who went 1/3 of a mile. I'll put my X down. Boys and girls, I hope you are showing this, because you are going to be showing this spiral math today in Flipgrid, because I really want to see that you've done all this work. This is a lot, and I want to see that you were able to get it done successfully today. So that was 1/3 of a mile, and there's one other person that's got 1/3 of a mile. So I'll put them down. They are 3 X's. So they're the most people walked 1/3. Oh, copy error. I meant to put that. Just note here, I made a little copy error. And I should have put it right here over 1/3. I wasn't paying attention to where I was putting my X. Now it's better. So now what I've got is I've got my title, miles walked in miles. I've got all my fractions labeled down below, and I put the X's down to show each person who went each distance. So I'm pretty much done with making my line plot chart, but there is more to do here on this. They also asked to find the fair share. And you see that question down here too, as a question. What is the fair share? And that's what we'll do next. I'll make an answer sentence saying the fair share is, and if you remember, fair share means that if you added up all of the distance that everybody walked and then divided it up so everybody would walk the same distance, that's the fair share. And since nobody walked more than a mile, we're only going to have the fair share be a fraction of a mile. So what I'll do is I'll say the fair share is blank of a mile, because I know I'm going to be getting a fraction for that. So I might as well just write in of a mile. Now the next thing I'm going to do is it is time to do some adding. I'm going to add up all the fractions that are listed here by the X's, and then I'm going to write them here, add them up, and then I'll be dividing by the total number of people. Let's go ahead and take a look at my first fraction right here, which is 1/5. Since there's only one person for 1/5, I'm just going to go ahead and write the fraction 1/5 one time right here. I'm going to be adding to that the number of people that are going 1/4 of a mile. Now for 1/4, I have 1 and 2 X's right here. So now what I'm going to do is I'm going to put those two fractions here, 1/4 and 1/4. Because there's 2 X's, that means that I need to put 1/4 2 times. I'm going to be doing the same thing for 2/5. If you look right here, I've got 2 X's for 2/5. That means 2 people went 2/5 of a mile. So what I'll do is I'll take those X's and I'll put them over as fractions. Since I had 2 X's here, I'm going to write 2/5 2 times. 2/5 plus 2/5. Okay, the next one I'm going to look at is 1/3. Now, it looks like here with 1/3, I've got 1, 2, 3 X's. That means 3 people went 1/3 of a mile. So what I'll do right over here is I'm going to put down 1/3 3 times to add them up. 1/3 plus 1/3 plus 1/3. Just got a few more to do. Now I'm looking at 1/2. Right here I have 1/2. Looks like I've got 2 X's. That means what I'll do is I'm going to write down here 1/2 plus 1/2, because 2 people went 1/2 of a mile. And finally, what I'll do is I'll look at my 3/4 of a mile. We have, again, 2 X's. That means 2 people went 3/4 of a mile. So down here, I'm going to add, finally, 3/4 and 3/4. I'm going to add up the distance that both people went that went 3/4 of a mile. Now it's time to do some adding. So what I'll do is I'll go ahead and the 1/5 I don't have to really do anything with. So I'm just going to move 1/5 over. Be ready to add that up. My 1/4 plus 1/4 I'm going to add up. That's going to become, well, just so you understand what I'm doing, I don't want to jump ahead here. So my 1/4 plus 1/4 is going to equal 2/4, which is equivalent to 1/2 when I simplify it. 2/5 plus 2/5 equals 4/5. I can't simplify that. Now my 1 plus 1/3 plus 1/3 plus 1/3, that I'm going to just show the adding right up here on this side, which is 3/3. 1 plus 1 plus 1 equals 3, 3 over 3. That's going to simplify down. So what I'll do is I'll turn that 3/3, I'm going to write it as 1. When I add my 1/2 plus 1/2, I get 2/4. Oops, I shouldn't be adding the denominators. I can't believe I did that. 1 plus 1 is 2. And I don't add my denominators. 2 over 2, well, again, that's going to turn into 1. My 3/4 plus 3/4 is going to equal 6/4. That one I'm going to simplify down. This is a really detailed problem, boys and girls. There's a lot going on here. So just follow along each part. Make sure you're adding this in. Make sure that you're showing all your steps because we are going to be showing this to me in a Flipgrid video later on. So I want to see how you did on this one. So 3/4 plus 3/4, 6/4. If I took 6/4, I could turn that into a mixed number of 1 and 2/4, which I could simplify down even further to 1 and 1/2. That means that I can now put that right here as my other addition, 1 and 1/2. My finals, well, actually not. Second to last step before I get my fair share is I have to take these, and I'm going to just line them up here so you can see it. I'm going to take these fractions right here in mixed numbers, 1/2, 1, 1, 4/5, 1/2 plus 1/5, and add them all up. And then I'm going to divide. So the first thing I want to do is I want to do the easy addition first. So some easy things I can do. I could definitely have this easy to add up, this 1/2, 1 plus 1 plus 1/2. I'm going to add those up and put those right over here. 1 plus 1 plus 1 is 3. That's going to equal 3 and 1/2 total. So all those together are going to be 3 and 1/2. All right, so I got those done. And I'm just going to cross out that so I know that I'm done adding those up, so I don't have to add those now. So I'm looking here. Oh, I see something easy. I have got, oh yeah, I've got two fractions with the same denominator, 1/5 and 4/5. I can add those up. 1/5 plus 4/5. So I'm writing it over here, so I'm doing my addition over here so you can see what I'm doing. So I'm going to take these two, 1/5 and 4/5 that I did over here, and I'm going to add them up down here. So I'm going to go ahead and do that right now. Going to add up 1/5 plus 4/5. Well, that equals, I know it's going to be 5/5 when I add them up. So I know that also that just translates into 1 whole. So I'll put that right underneath my 3 and 1/2. So now I've got those two done, and I've added them up. So I've only got one fraction left to add in. And the one fraction I've got left to add in, boys and girls, is 1/2, which is right here. So what I'll do is I'm going to drop down that 1/2 and add that, line that up right underneath. Just to make it easy to add, I'm going to add 0 and 1/2. That way I'm not getting out of line here. Now I'm ready to add up all of the distances that everybody walked to get ready for my fair share. What I'll do is I'll take 1/2 plus 1/2, that equals 2/2, which is the same as saying 1. 3 plus 1 is 4. So I have 4 and 2 over 2, or 4 and 1. So I'm going to add this together, 4 and 1. The total is going to be 5 miles. Now that's not the fair share yet. That's the amount of miles that everybody walked together. All these people together walked a total of 5 miles. The fair share now is I have to take that 5 and I have to divide it up by the number of people that actually walked. So what I want to do is to find that number. I'm going to go up here. Well, first I took my 5 and I'm putting a dividing sign, so I'm going to be dividing. And I'm going to go ahead and count all the number of x's. These are the total number of people that walked. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to go check one more time to make sure that I've got it correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my total number of people that have walked is 12. I counted up all the x's to find that. The next thing I want to do is I'm going to be dividing to get the fair share. So I'm going to take 5 miles divided by 12 total people. And I mentioned this before, one of the easy things you're going to see is that you don't have to actually divide. You can make this into a fraction, which shows the dividing. What we do is we take and put a fraction bar in our quotient area, and we're going to move the 5, that's the total number of miles, up here in the top. 5 miles, I'm going to say divided by the number of people, which is 12. When we set up the division like a fraction, now we get our fair share. We can say that 5 divided by 12 is 5/12 as a fraction. That means that each person, the fair share, each person would walk 5/10, or no, not 5/10, 5/12 of a mile. So I'm going to go ahead up here to my answer sentence and write the fair share is 5/12 of a mile. And that is a very long answer for the first one. Boys and girls, make sure you have this all in here. Like I said, you're going to be showing this on Flipgrid today because I really want to see how you did on this one. This is a tricky one and a lot of work, and I want to just see how you did. Let's move on now to number 2. Let me go over to the other side, put my answer and my work. We'll go ahead and take a look here. It says, use the information in the table to solve. Phil walked the scenic overlook and bird watching trails in 3 hours. About, ooh, there's that word, about. How many yards did Phil walk each hour? Now that about means that I'm going to be doing some rounding here and some estimating. So I want to keep that in mind while I work on this. What I want to do first, though, is get an answer sentence. So I'm going to say, said about how many yards did Phil walk each hour? I'm going to say Phil walked about. And putting about in the answer sentence is going to remind me that that's going to be important for me to round and estimate while I'm working on this problem. Phil walked about blank yards each hour. Okay, I've got my answer sentence ready. Now I want to carefully read the word problem to make sure that I'm doing exactly what I need to do in terms of solving it. It says here, Phil walked the scenic overlook and the bird watching trails. Now, if you notice, it does not say anything about the wildflower trail. So I don't need to use that. Don't be a number monkey, boys and girls, and just look at all the numbers and add them up. Wildflower trail is not in there, so you don't need to put that into the solution for the word problem. So Phil walked the scenic overlook and bird watching trail in 3 hours. So what I'll do is the first thing I want to do is I want to take and add the distance that Phil walked in yards for the bird watching trail. And I also want to do it, add it in for the scenic overlook trail. So what I want to do is right now, I'm going to put those in. Take the amount for the bird watching trail, which is 1,800 yards. The scenic overlook trail, which is 900 yards. And what I can do is, let's see, I'm going to take a look at this right here. 1,800 and 900 yards. There's a couple ways you could do this. One thing I noticed is that when I add these up, I get 2,700 yards. If I wanted to take 2,700 yards and divide that by the number of hours he walked, that's actually a pretty even math fact. 27 divided by 3 is 9. And I just drop down some zeros. So I get a pretty nice easy division. I actually don't have to really do that in any sort of complicated math. It's just almost even a mental math fact. So I could say that if you wanted to, Phil walked about 900 yards. You could also, if you were rounding this, a great way to round this down, which you could say is, you could say that Phil walked about 2,000 yards on the bird watching trail. And I could round the 900 to 1,000. And this is actually the estimating way. I'm just saying if you went the other way, I could understand why you went that way. But if you're estimating and rounding, you want to round it this way. 1,800 is about 2,000 yards. 900 is about 1,000 yards. I get 3,000 yards, which if I'm going to divide that by 3 is very easy to do in my head. 3,000 divided by 3. And the reason why I'm dividing by 3 is because that is the number of hours that Phil walked. We want to find out how many yards he traveled in 1 hour. So I'm going to take 3,000 divided by 3, which I can do in my head mentally. 3 divided by 3 is 1, and just add 3 zeros. So now I know that as my estimate, Phil walked about 1,000 yards each hour. All right, let's go ahead and go down to number 3. On number 3, Sophia, Caitlin, and Morgan wanted to see how far they could run in 5 minutes. Sophia ran 1/2 mile. Caitlin ran 9/10 of a mile, and Morgan ran 2/3 of a mile. The question here is who ran the farthest and by how much? So actually what we're doing is we don't really need the 5 minutes at all. That actually is just number monkey extra information we don't need. We do need to, we're not going to add them up. We're not really going to be doing anything with these numbers except comparing them. We want to see who ran the farthest. So we want to see which is the biggest fraction and then say by how much. So that means that we want to take a look and find the biggest fraction, and then we want to compare it to the second biggest fraction. So first of all, I'm going to take Sophia. Sophia ran 1/2 mile, so I'm going to write that here. And I'll be comparing it to the amount that Caitlin ran. And Caitlin ran 9/10 of a mile. There's a couple ways you could compare these two to see which one's the biggest fraction. I could cross multiply by doing it this way. What I could do is I could take 2 times 9, and that'll equal 18. Then I could take 10 times 1 over here and get 10. Now, boys and girls, a lot of you I know will probably look at these fractions and say, yeah, it's pretty easy to tell that 1/2 is smaller than 9/10, but I just want to prove it by doing some cross multiplying. That means that the 9/10 is a lot bigger. So I am going to say that Caitlin, this is Caitlin's looks like she's the biggest one here. But let me go ahead and check a look at Morgan's just to make sure. So I'm going to go ahead and put Morgan's right over here and compare it to Caitlin. So here's Morgan's 2/3 of a mile. I want to compare it to Caitlin's just to make sure that it is the biggest. So I'm going to go ahead and write it here. I'm going to compare them by cross multiplying. So what I'll do is I'll take 3 times 9 and get 27 over here. I'm then going to go ahead and cross multiply 10 times 2 and get 20. And it looks like Caitlin's is still the biggest fraction because 27 is bigger than 20. So we know that Caitlin is the biggest. So that means that Caitlin ran the farthest. So I'm going to go ahead and start my answer sentence right here by saying Caitlin ran the farthest. Now that's not all I have to do. I have to also say by how much. When they talk about by how much, that means how much more did she run in the second biggest distance or the second longest distance? Well, so what I got to do is I got to find out who actually ran farther, Morgan or Sophia, because they're the other two people running, and I want to make sure. So I want to look at Morgan's number and Sophia's number. What I'm going to do is see which one is the biggest here. So I'm going to look at 2/3, which is Morgan's distance of a mile, and Sophia's, which is 1/2 of a mile. And I'm going to compare them. So what I'll do is I'll compare them by doing cross multiplying. 3 times 1 is 3. And then I'll multiply 2 times 2, which is 4. 4 is bigger than 3 when I cross multiply. So that means that 2/3 is the bigger fraction between Sophia and Morgan. So that means that I want to know, well, I know now that Morgan ran second. She's the second farthest. And knowing that, I want to know, so how much farther did Caitlin run than Morgan? So what I want to do is the next step is I want to take Caitlin's distance and I want to write that down, 9/10. And I want to find the difference between how far Caitlin ran, which is 9/10 of a mile, and I want to subtract how far Morgan ran. So I'm going to take 9/10, subtract 2/3 of a mile. When I do that, boys and girls, I'm going to go vertical. I'm going to go 9/10 minus 2/3. Easiest way to find a common denominator here, boys and girls, is to take 3 multiplied by 10 to get 30. I'm going to put 30 underneath each one. 3 times 10 equals 30. So whatever I do on the bottom, I'm going to do on the top. 2 times 10 is 20. You can kind of see the 2/3 right there. 20 over 30, that's an equivalent fraction. Right here, I'm going to take 10 times 3 to get 30. And whatever I do on the bottom, I'm going to do on the top. So 9 times 3 equals 27. So now, boys and girls, the good news is that I have a denominator that's the same, and I have a top fraction that is bigger than my bottom fraction, which is always good. So I'm going to subtract 27 minus 20, and that's going to equal 7. I'm going to keep my denominator, which is 30. I can't simplify this fraction. 7 is a prime number, and I can't divide anything by 7 and by 30 to get the same, or with the same number. So that means that Caitlin ran 7/30 of a mile farther than Morgan. And I'm going to write that right here. Caitlin ran the farthest. She ran 3/10 of a mile more than, and our second place person was 3/10 of a mile more than Morgan did. So Caitlin ran the farthest. She ran 3/10 of a mile more than Morgan did. All right, boys and girls, I'm really proud of you for checking your work, sticking with it, and making sure that you're doing everything correct. If you have any mistakes, you know what to do, and you're making those mistakes, or you're fixing those mistakes. I'm going to go ahead and grab another piece of paper because these today are taking up a lot of space, and that's okay. I'm going to go ahead and just put down a new piece of paper, and we'll go through for number 4. On number 4, I want you to go ahead and I'm going to put answer and work. And again, boys and girls, keep your papers because I do want you to show them to me for today's spiral math. Instead of a survey, I'd like you to just go ahead and show me on Flipgrid because I'd love to see all the work you've done on this, see how you fix your mistakes, see how you corrected things and labeled them. So let's go ahead and go down to number 4. On number 4, we're taking 5 1/2, multiplying it by 7/9. So I'll go ahead and write down an expression for my answer sentence here. 5 1/2 multiplied by 7/9. Now, when I look at this, when I multiply fractions, I'm going to need 2 fractions to multiply. I've got 7/9, so I can leave that alone. But I can't multiply this mixed number yet. I've got to turn it into an improper fraction. So what I'll do is I'll take 5 times 2 is equal to 10. Add 1 more, that's 11. I'm going to put 11 over 2 is my new mixed number because 5 1/2 equals 11 over 2. Then I multiply straight across. 11 times 7 is 77. 2 times 9 is 18. Now I have an improper fraction that I need to turn back into a mixed number. To do that, I'm going to take 77 and put it in a dividing box. And yes, Ethan, I am going sideways now because it's important. And I'm going to divide that by 18. And I'll put that right here. Now I'm going to multiply, let's see, I think 18 times 5, I'll start with that. Oh, that's 90. That's too big. Let's try 18 times 4. 32. Oh, that's pretty close. 72. So I'm going to put an X over my first 7. 18 times 4 is going to equal 72. 77 minus 72 is 5, so that's my remainder. What happens now is that the 4 becomes my whole number in my quotient, in my product. So what I'll do is I'll take the 4 that I found when I divided and place that right here as my whole number in my product. 4. Now I've also got a remainder. That remainder was 5. That 5 is going to become the top of a new fraction. 5. Then I'm going to look at my denominator. My denominator is going to be the number I divided by, which is 18 right here. I'm going to use that 18 to make my fraction denominator. 5 over 18. Looks like I can't simplify that 5/18 because I can't divide 5 and 18 by the same number. So my product is 5/2 times 7/9 equals 4 and 5/18. All right, let's move on now to number 5. All right, we're going to take number 5 right here. And I'll just, I think to save a little bit of space, I'll say it's okay to use a little bit of work below here. So what I'll do is I'm going to be taking 4/10. I'm going to compare it to 2/5, which is actually what we just did a few minutes ago when we were comparing some fractions. So what we'll do is we're going to cross multiply to compare to see which one's bigger, 4/10 or 2/5. To cross multiply, I'm going to take 2 and 10 and multiply it by 2. 10 times 2 is 20. Then what I'll do is I'll cross multiply again on the other side by starting with the bottom 5 and going up to 4. 5 times 4 is, 20. Well, 20 is the same thing as 20. So that means that 4/10 is equal to 2/5. They're equivalent fractions. All right, let's move on now to number 6. On number 6, I'm going to write the number in word form and expanded form. So I'll write my answer sentence, the number, and make sure you use the words word form so I know what you're going to be doing. And on this, boys and girls, it's very important, oops, kind of blew away there. It's very important, boys and girls, that you remember that you are going to be spelling things correctly. Very, very important. So look here at my word form, and remember spelling does count. So I'm going to check to make sure I'm spelling correctly. So the number in word form is 2,000. Because there's a comma after the 2, I'm going to write a comma there. 2,000. There's a 0, so I'm not going to write anything after that. Then I'm going to put 14. 14. Notice how I spell 14. 14, and just plain old 14. 2014. I've got a decimal, so the next thing I'm going to do is I'm going to write and. That's the only time I write and is when I have a decimal. And 300. And the reason I'm starting off with 300 is because if I look at this number, decimal by itself, I see 307. And then I'm going to add in the place value of the last digit, which is thousandths. So it's going to be 307 thousandths. I don't know if you can hear me over the computer that I am exaggerating my thousandths. To remind myself, it's a thousandths place. All right, make sure you have the THS on the end there. The next thing I want you to do is we're going to be doing this in expanded form. So what I'll do is I'll say the number in expanded form is and on this time, I'm just going to write it out expanded. So I'll be putting in parentheses 2 times 1,000 for 2,000. I don't have any hundreds, so I'm going to leave those alone. I have 110, so I'm going to pick 1 times 10. And I have 4 ones, so I'm going to put 4 times 1. Then I'm going to be adding in my decimals. I'm going to have 3/10. 3 times 1 over 10. I'm going to have no hundredths, so I'm going to go right to thousandths, which is 7 times 1 over 1,000. Now I could have made these decimals. I could have done this as 0 and 1/10, and this could have been 0 and 1. Oh, not 100ths. That's a copy error. Let's put that down as 0 and 1,000. You could have done it that way too, boys and girls. So make sure you have your parentheses, 2 times 1,000, plus 1 times 10, plus 4 times 1, plus 3 times 110, plus 7 times 1 over 1,000. All right, let's go on down to number 7. Now, number 7, a group of 100 light bulbs, in a group of 100 light bulbs, 7 were defective. Or not 7. Let's read that again carefully. I should have read that a little bit slower. In a group of 100 light bulbs, 23 light bulbs were defective. Write this number as a decimal. Okay, so let me write this as the number as a decimal is. Now the way to do that the way I'm going to do it is I'm going to first take and write a fraction to show the number of defective light bulbs. I know that in the word problem, it's telling me that there were 100 total light bulbs. This is kind of making me think of the city of Emma right now. There are 100 light bulbs. So I'm going to put down here as my denominator 100 total light bulbs. But there are 23 out of those 100 that are defective. The 23 is my numerator. So I'll go ahead and put 23 on top as my numerator. So now I have 23 out of 100. Which if I read that, I get my decimal, 23 hundredths. And there's my decimal. I just have to write it out in decimal form. So 23 hundredths is, as a decimal, 0, decimal dot, 23 hundredths. And there's the decimal. Let's move on. I think I've got just enough space here for number 8. Write the fraction in simplest form. So I'm going to go ahead and put 24 over 40 equals, to show my simplest form. And on this one, I'm going to start off by dividing them both, since they're both even numbers, by 2. I get 12 over 20. Now, when I look at this again, I still have 2 even numbers. So I'm going to do it again. 12 divided by 2, 20 divided by 2. 12 divided by 2 is 6. 20 divided by 2 is 10. Oh, they're still even numbers. So I know I can divide both of them still by 2. 6 divided by 2 is 3. And 10 divided by 2 is 5. Now I get to a point where I can't divide them by 2 anymore, and I also can't divide the 3 or the 5 by the same number. I'm done simplifying. Now, another way I could have gotten there is I could have taken 24 divided by 8 and 40 divided by 8, which is the greatest common factor of both of those numbers, and I would have gotten the same answer, except without a lot of the other dividing. So I could have taken 24 divided by 8, 40 divided by 8, and gotten 3/5 as well. Either way, you should end up with 24 over 40 equals, as a simplified fraction, 3/5. You could also write that as a sentence saying 24/40 in simplified form is 3/5. Either one's okay. All right, boys and girls, thank you for sticking with me through this very long spiral math checking session. I'm glad that you checked every one of your problems, and I'm glad that you also fixed your mistakes. What I want you to do now is I want you to take this work, and I want you to go over, click on the link for Flipgrid, and I want you to show me all of your work, show me all your answers, and tell me how you did. Did you get 100%? Did you miss a few? Did you miss a lot? Let me know how you did on this one. And thank you for doing this video with me, boys and girls, and I look forward to seeing your work for today's spiral, or Wednesday's spiral math. Thank you, boys and girls. Bye-bye.